Hi all, welcome back to another lecture of DBMS. And in this lecture, we will learn about enhanced entity relationship features. So what are the few enhanced features in ER? And those enhanced features are generalization, specialization, aggregation, union, inheritance, and compositions. And we will learn about all these enhanced features in more detail in this video. So stay tuned and let's begin with today's session. First topic is enhanced entity relationship feature. So what is this enhanced entity relationship feature means? So these are the extension of the basic ER model. So whatever relationship and whatever basic parameters we have seen in the ER model, out of those enhanced entity are the extensions of the basic ER model to better model complex relationships and constraints. So basically they enhance the ER model to express complex real world scenarios. Out of those, generalization, specialization, aggregation, union, inheritance, and compositions, these are the enhanced features which makes the complex relationships to be understandable for the real world scenarios. So together these features enrich the ER model, making it more adaptable to complex real world application and enhance its ability to represent the data relationship. So this is what all these enhanced parameters meant of, and how it actually helps to understand the more complex real world scenarios via the ER diagram more easily. Okay, so let's start with these parameters one by one. So out of which very first is generalization. So what exactly generalization in this enhanced feature means? So generalization is a data modeling technique. It simplifies the representation of the entities by identifying and extracting shared characteristics to form a higher level entity. So basically, it simplifies the representation of entity by identifying and extracting shared characteristics. So when some of the attributes are common in two entities or multiple entities, so basically it extracts those shared attributes or shared characteristics and form a higher level of entity. So in this example, you can see that employee and customer are the two entities, and obviously name, phone number and address were the common attributes for these both two entities. So instead of making it in the same and allotting it in the same entity as an attribute, we have created a new higher level of entity called and given the name as person, and the attributes name, phone and address which were shareable in those two entities, we have made a new one. So both employee and customer have common attribute such as name, phone and email. And by using the generalization process, we created a generalized entity called person that encompasses these shared attributes. So this is what a generalization means, which makes the, instead of making it adding the same attributes and making this table too bulky, we have chosen a new generalized way where we have created a new of higher level entity and given the shared attribute in it itself, so that we can use it, and it will look more simple and lightweight. So that's what generalization means. Next is specialization, and this is totally opposite to what we have learned in generalization. So in this generalization, you can see it's a bottom to up approach, right? So we were in the bottom one, and whatever the common attributes we were getting, we have created a new entity and given those attributes to it. In the specialization, it's top to bottom approach. So specialization is a data modeling technique that allows for the division of higher entity into two or more specialized lower entities. Okay, so in this, from person we have created employee and customer. So it can be two or more than two. So here the generalized entity person can be specialized into employee and customer. Okay, and each representing distinct roles. So what happened when we have a person entity and name, phone and address, but let's suppose we have this table itself, but now when new new request come saying we will be giving you some person, but for some person there will be salary, whether for some person we will have your email ID or customer ID or credit also. But for the another person, it might happen that credit and customer ID does not depend. So in that case, making a table, right, and making that space empty. Let's suppose credit. Okay, so the employee which do not have credit, will lie here, right? Not in customer. So we will have to make this null value as an empty. So instead of making those cells as an empty, we have decided to create two different lower level entities. Okay. So out of which name, phone and address are common. So obviously they will be sharing that, but those extra parameters which do not even exist in the another, like I suppose customer, so which are there only for employee. So we have created a lower level of entity called and named it as employee and given as only employee ID and salary as an attribute for it. When we got some list of people who do not have salary or employee ID, whether they have customer ID, credit and email ID, we have created to store such information data. We have created a lower level of entity and we have given the name as customer. So specialization is totally opposite to generalization. In generalization, whatever we have entities, whatever the common characteristics are, we basically take those characteristics and create a higher level of entity. And in specialization, we have already a higher level of entity. Some of the data, for some of the data, some attributes might not be present. So instead of making and keeping it vacant or null, we will divide into two lower level of entities, considering what are the parameters present for those tables, right? Next is aggregation. So aggregation is a data modeling technique and it allows us to treat relationship as a higher level entities and allow complex relationship. So it helps us to treat the relationship as a higher level entities. So let's suppose here this project employee and machine, right? So we have a project that is associated with employee and machine, yes, and the works for is the relationship between the project and the employee, and it indicates that because we have given two lines, right? So basically it's a multiple. So it indicates multiple employees can work on a single project. So it gives, from this way, it gives one-to-many relationship. While the require relationship shows that each project requires different types of machinery. So here each project requires different type of machineries to complete. And similarly, it can be vice versa also, like a single piece of machinery can be used over multiple projects. So it can be many to many relationship. So this is how aggregation shows. Like you can see this require relationship exists between a relationship and an entity instead of entity and entity, right? So this is what aggregation helps to make the relationship as the higher entity, right? So that's what the meaning of aggregation in the ER model means. Next is union. So by the name itself, you can say the common part we take it as collective is called union, right? So we have two tables and we have some common parts in it. That will be the union result. So what happens? It is also called a category and it is a feature where one entity type represents a union of entities from different entity sets. So basically here let's suppose we have a car entity and a truck entity. For both car and truck entity, we have a license plate for it. So basically it defines which type of vehicle it is. So instead of giving it as an individual, we have created a common higher level of entity and we have given that name. So license plate is a unique identifier for all vehicles and we know that. And a registered vehicle is a generalized entity that represents both cars and trucks. So this is the entity of registered vehicle and it stores the license plate and all the license plate uniquely identifies each car or truck, right? So this is what union comes and this is what union brings the meaningful thing in the ER diagram. And that's how we basically separate this union basically common thing from these two entities. So instead of these two, it can be multiple entities also, but what are the common things and which basically uniquely identify as well, we keep it in the higher level of entity and called is at union. Next is inheritance. So inheritance allows entities to inherit properties like how we do in object-oriented programming. We make a parent and whatever child we make, the children will inherit the properties or attributes of the parents, right? So it allows entities to inherit properties and relationship also from other entities. It basically established a hierarchical structure where a parent entity can pass down its attributes and behaviors to the child entity. So here a parent entity can pass the attributes or relationship to the children entity. This promotes the schema resize and simplifies the modeling process. So basically it helps to simplify the modeling process because instead of recreating those parameters again for the children, it is better to inherit from the parent class. So here instead of parent class, we'll say parent entity. So this is how, like, let's suppose this is an example of person, right? And we have a passenger and a teacher entity. So we know for both passenger and for both teacher, we'll be having user ID, name, and phone number as common. So being the children and the inherited, entity from the parent person, so it can have the right to, use these three attributes of it, along with their own individual attributes also if they want to add it. So this is how, like, how object oriented programming, gives that functionality to the OOPS concept. Here also it gives the same functionality in form of entities. Next is composition. So basically, it represents a strong relationship between the entities. It indicates a part of relationship where the child entity cannot exist independently of the parent entity. And if the parent entity is destroyed or deleted, the child entity will also get destroyed. So this is what composition means. It shows the strong relationship or the strong entity. Strong entities are those which can exist without any other entity. They exist independently. But the weak entities are those which cannot exist independently. It always needs someone to exist. Like if you have a customer table, it is strong independent. But if you have an address table, so address table should only exist when customer table should be there. If customer table deleted, there is no mean of existing the address table. So in that case, if the parent class deleted, the child class also needs to be deleted. So from this example, you can see that if we have a car entity and we know that car or driver, the relation between car and driver entity is drives, okay? And we have door entity, tires, engine, and seats. And these are weak entities. Like these entities cannot exist if car entity does not exist. So basically that is all about composition, means that it shows that a car is composed of engine, wheels, seats, and tires. Each of these components is essential for the car to function, but they cannot operate independently outside the context of the car. So this is what composition means. It shows the strong entities or a strong relationship between the entities. And that was all about the different types of enhanced features of ER. I hope you learned. Now let's meet in another lecture. Till then, keep learning, take care of yourself and your family too.